is NetMaven. Today we're focusing on the Nexus Dashboard Fabric Controller. We're going to build this lab. The Nexus Dashboard Controller NDFC is the next generation of DCNM Datacenter Network Manager, which is network management platform for all NXOS enabled deployment. In this app, only the setup of the Nexus dashboard is done for you, and you will be hands-on with Nexus Dashboard Fabric Controller completely from ground up to discover how easy it is complete setup. So then we're going to create the various types of fabric for this greenfield deployment, external connectivity, multi-site deployments, and corresponding with inter-site deployment. And all this through the embedded automation within NDFC for VXLAN EVPN fabrics. And we will then shift into the role of network automation engineer and get started with using the Ansible NDFC collection to help manage my VXLAN EVPN multi-site fabric to conclude the entire lab. So for this lab, each site we have DC1, which is AS number 100, DC2, AS number 200. We have a leased data center, are a brand new fabrics, and the inter-site network ISN fabric to be used with a multi-site domain we call MSD fabric. So both DC1 and DC2. For this lab, each data center has a topology. They are all brand new fabric. The inter-site network ISN fabric is having my core router AS number 777 and can be used with the multi-site domain MSD fabric. Both DC1 and DC2 have Linux servers connected to their normal leaf switches for data plane testing after NDFC handles all the deployment of each of these fabric types. Logging to the fabric controller. The first step, we're going to create a fabric. The first fabric we're creating is DC1, and you choose Datacenter VXLAN EVPN is a fabric for VXLAN EVPN deployments with Nexus 9000 3000 switches. Select this. Now the AS number will be AS100, so we'll pick 100 for the BGP AS number, and we would like the underlay subnet IP mask to be 31, and go to replication. We would like to underlay RP rootback ID to be 251. Okay. For the next, we'll go to advanced. In advanced, we will go to is the green fields cleanup option here. We enable it, and we come back up to the resources. We wanted to define the IP pools to be used for routing loopbacks for IBGP EVPN peering, the VTAP loopbacks, and the spine RAPI loopbacks, and the physical interfaces to use for the entire underlay. So let's define the underlay routing loopback IP range, which is my 10.11.00. We define everything for 20/24. Underlay VTAP, we'll do 24, 10.251, 251 for the underlay RP loopback, and underlay subnet IP range, let's do 10.1.00/24. Keep scrolling down here, scrolling down. We find VRF light deployment, and here we go to back-to-back on the two XML. We will check all the port for peer, all the port for default VRF. Okay. Keep scrolling down. Here we have VRF light subnet IP range 10.31.00/24. Now let's click save. Okay. All right. Double click my DC1. Next, we will be adding the switches. First switch, we're adding the DC1 switches. Uncheck this preserve config. All right. Click feel this better. Discovery switch. Click confirm. We'll be finding the switches. We're going to find all the switches. Okay. Check DC1 switches and we'll click add. Is in a process adding all the switches. We're adding leaf, spine, leaf 2, leaf 1, and all the switches. Now we have the switches added. Let's close it. We wanted to wait all this migration mode to normal. Click my spine. As you can see, my spine has an external connectivity to the multi-site ISN. So we would like to set this role to be a border gateway spine. Okay, we assign this border gateway spine. For the next, we want to go to the interfaces. We go to the interfaces and we want to contain MGMT. We'll do one thing because this MGMT on each of the interface, we want to, disable the CDP, make sure CDP is disabled. Deploy. See, and we're shutting down the CDP, and that's fine. We don't have pending because it's already down. Cancel that, and go to interfaces. Let's go to switches. We'll see the border DC1 spine 1 is set to a row border gateway spine. As you may know, for Nexus 9300 switches, the default row is set to a leaf here, whereas the 9500 switches, the default row is set to a spine. The switches that need to assume the roles of the border leaf switches or border gateway leaves switches, for example, need to have the role set appropriately. For example, if I have a role for the leaf and connected to the external, then that would be a border leaf. Okay. So I'm satisfied with the role here. We'll go to the blue action and click recalculate and deploy. Now I'm seeing all the switches are out of sync. I will do a recalculating and config on the switch. So let's do it. So I'll see if hundreds of lines will be added to the controller. Let's deploy them. It will take a bit of time. That dashboard fabric controller will add all of these configs to my switches, leaf 1, leaf 2, and a spine 1. Okay, let's just wait it up. Let me pause my video till all these process get complete. All right, we can close it out. What is next step we're gonna do is create the DC2, which is my AS200. Close this and action to create add a fabric called DC2. We'll choose the same type of fabric as Datacenter VXLAN EVPN. Choose this. Add a general parameter. We'll fill in 200 as BGP AS number. Here we'll pick it 31 for the subnet mask. Choose replication here. We still use 251 as the RP loopback number. All right. So that's about it. Then go up, find advanced. We wanted to do a cleanup. Greenfield cleanup is click enable. Scroll up to the resources. Where here we define the IP ranges. We're taking 10.22 for the routing loopback IP range. Was 10.222 as my VTAP loopback IP range, and RP loopback IP range. We are going to pick 252.252/24. Okay, pick a subnet 10.2.0.0/24. That's for my underlay subnet. So keep scrolling down, pick it back to back, and we'll pick auto deploy. So that's about it, and save. We're creating DC2 fabric. All right, so go to DC2 fabric, double click it, and navigate switch. We are going to add a switch. We're adding a C switch. Uncheck the preserve config and hit discovery. So now we're going to pick the DC2 spine, add a switch. All right, we're going to continue adding the other one. Close this first. Uncheck preserved config and we'll discover. We're adding the DC2 and DC2 border leaf, and the diagram shows DC2 adding the switch. Successfully added to 2 switches. We'll take a look at DC1, how the role assigned. This will assign the same role to the switches for the spine 1. Double click DC2. The DC2 spine will assign a role to be my border gateway spine. Add a border gateway spine right here. Now everything else will look the same, and just border leaf is gonna be a little bit different. Here is not a leaf. We're gonna set a role here. We'll want it to be a border. checklist. Now this switch which is showing as a border. Okay, and we'll go to the interfaces, find interface MGMT0. I'm going to add it off the interface and we'll disable the CDP. And next, sorry, disabled fine. Deploy. Okay with config, it's just disabling my MGMT0. All right, close this. We'll do blue actions and recalculate deploy. The hundreds lines to add it, then deploy it all. Now we close this. Let's take the topology. I have created two data center. DC1, DC2 are two fabrics. Next, we're going to create more fabric. The other fabric we want to create is called ISN Interset Network. With my DC1 and DC2 fabric created and deploy all of its roles and configurations, they are created. The next step is to move them into MSD, but before that, the fabric needed to be created for the router that will act as the intersite network ISN, providing the connectivity between the data centers, and the fabric controller can fully manage these devices as well in fabrics. So what we'll do, I'll create ISN fabric and choose a network as external connectivity network. Okay, in here we will provide my AS number, that will be 777, and uncheck the factory mode so I can configure this, and that's safe. So ISN networks created, double click. We'll add a switch. We'll add this switch as a core router. Okay. Discover. Okay. Add this core router switch. Close this. We'll check the management interface. See the interface CDP is disabled already. We're good. And go back to switch. We want to set a role. This role will be my core router. Select this. Okay. Blue actions. We calculate deploy. Now close it. Close it. In topology, we can see I have a connect ISM fabric to the two data center. For now, we're good, and go to the fabric. We want to create my MSD. MSD is going to be my external multi-site external network. Is gonna be a domain. Okay. In here, Fabric Controller can manage multiple VXLAN BGP VPN fabrics, while also hopefully easy provisioning and management of the layer 2, layer 3 DCI underlay configuration among these fabrics using a special constructor called this MSD, multi-site domain fabric. A multi-site or VF Lite or VF Lite IFC will by manually configure the link for border devices in Fabric or by using this automatic deployed border gateway methods. Okay, that's pick it around Fabric, and we wanted to use this VXLAN EVPN multi-site. This is what I want. Okay, just remind you. We will leave everything in general parameters saying here, default, but the multi-sites, we want to use these directly to BGWs. In that sense, the EVPN neighbor will be created crossing my SN between the border gateway spine and border gateway spine. Okay, and it will be IPv6 neighbor to the core router. So there are two kind of neighbor for multi-site, and that site-to-site EVPN neighbor will be choosing directed BGWs. Okay, and the multi-site underlay here we want to use the auto deployment flag. Go to resources. We'll keep the resources the same 10.10 range. Okay, then save. Let's go into the MSD. One thing we'll do is to adding the fabrics as a child. Add a DC1. Let's add more DC2. Okay. Add my ISM. Don't forget that. Okay. When you add the child's fabrics, L3 VNI, L2 VNI ranges must be aligned. Okay. So bordered enough to include all VNIs used in the fabrics will be imported into the multi-site domain MSD. Since we're all greenfields, nothing VNIs or networks you have added, we can easily add into the MSD. Then we could create the network VFs and we'll do the attachment. Just in mind, if you have the network VF created in your fabrics before adding at the child in MSD, these VNI ranges should match what was used when you created your DC1 and DC2 fabrics. And you must also define the Anycast gateway MAC address that will be used across our site. When you're creating the fabric, you will see the MAC address you defined in beginning of the creation of the fabric. And the MAC address must be the same, in the DC1 and DC2 to ensure the consistent gateway behavior. So see, if I move a server to the DC2 and DC2 server to the DC1, the MAC address will be the same. It's especially important when you are having a vMotion crossing the site. Okay, so in this lab environment, I can define the same default value as provided. as their match was used in the side 1 greenfields deployment and the side 2 greenfields deployment. Okay, when every single deployed, we will recalculate and deploy. So in the MSD level, we'll see the deployment happens to the spine, border gateways, border spines, and a core router. The lines will be added, okay, as deployed. Okay, closed up. Now we wanted to go to the fabric, see the tree structure of the MSD domain. Go to DC1, go to switch. Okay, since we don't have any network VF, we don't have to deploy to the leaves. Okay, so that's showing none in sync, everything in sync. DC2 is the same. No deployments required for the leaf, border leaf. We don't have to go to command line and show you everything. We could go to the topology, check configuration, click ISM. This is what ISM show you right now. 2 DCs. Let's take a look at spine 1. Show BGP session. Have a full neighborship build up. Okay. Show IP BGP summary. This is the neighbor to the ISN core router. And then this IPv4. Show BGP L2 EVPN summary. 3 neighbors. 2 are internal iBGP. 1 is eBGP. And copy this. Go to DC2, spine 1 is border gateway spine, show IP interface brief. We could take a look, the IP is my loopback 1, so that's the neighbor. Okay, show IP BGP summary, and it has also a IPv4 neighbor to the ISN core router. Show BGP-L2 EVPN summary. It has the same 2 iBGP internally. And you have a one eVPN BGP eBGP to the DC1. You'll see is using update source loopback 0 as a back-to-back connection. Okay. In the core router, show BGP session, show IP BGP summary. The 2 neighbors are in the 2 data center, the DC1 and DC2. Okay, that's my first video. We are creating fabrics, we're adding them to the multi-site domain. So we have the backbone connection for the multi-site. Next, we'll be focusing on creating the networks, VIFs for the tenants. We have a tenant 1, tenant 2, and tenant 3. And tenant 3 is a shared tenant. It can be DNS server, NTP server, DHCP server, etc. shared, and will be leaking out the routes to the tenant 1 and tenant 2. Okay, and tenant 3 will provide internet access. DC to WAN is a CE router, Internet WAN router, and we have test machine in the simulation of the internet. And is all internet access will be via the tenant 3. Okay, tenant 3 is also a shared tenant for internet access. So stay tuned and we'll see you next video. Thank you.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.